In this first lecture in the generator section, we'll delve into the fundamental concepts of iterators and iterables in Python. Our focus will be on understanding these concepts in the context of real-world applications as we've gone through in previous lectures and hands-ons, the associated hands-on lectures reinforcing your understanding of the same. As before, we'll use various examples in the same three contexts that we have so far, these being streaming log processing, genome pattern recognition, and stock price anomaly detection. Let's begin with iterables. An iterable in Python is any object that you can loop over. Common examples include lists, strings, tuples, and dictionaries. These objects allow you to use them in a loop, like a for loop, to access their elements one by one. Consider a scenario in genome pattern recognition where you have a list of DNA sequences. The list being iterable means you can loop over it to process each sequence in the list of sequences. That is, loop over each item in the list one by one. Moving on to iterators, an iterator is a more technical construct that actually performs the iteration. It remembers its state during iteration, meaning it knows which elements have been accessed and which have not. You obtain an iterator from an iterable using the iter function. And you can also create custom iterators for specific tasks. When you use a for loop, for instance, Python internally converts the iterable into an iterator. This is done using the iter method of the iterable. The loop then calls the next method on the iterator repeatedly until there are no more elements left, which then raises a stop iterator exception. For instance, in stock price anomaly detection, you might iterate over a list of stock prices, as in the code displayed on your screen at the moment. Moving on to callables, in Python, a callable is any object that can be called like a function. This means that you can use parentheses and pass parameters to it if required. The most common examples of callables are actual functions and methods themselves. However, classes and instances of classes can also be callables if they implement the call method. As a class can be made callable by implementing the call method, this can be particularly useful in scenarios where you might want to create a class that can be called to evaluate, say, anomalies in stock price anomaly detection, for instance. In more advanced use cases, like in streaming log processing, you might find it useful to combine callables with iterators. For instance, this code example demonstrates how to design an iterator that processes each log entry through a callable. You have a class at the beginning called log processor with an init method, an iter method, and a next method. You then have a function called process log line. And finally, you have a variable declared called log processor, which is essentially instantiating the log processor class with the file name where the logs are stored and the actual function being passed as the second argument. As each log is returned by the process log line function, it is then processed within the for loop you can see at the bottom of your screen. In conclusion, we've explored the concept of iterables, iterators, and callables so far in this lecture and how they can be integrated for various different applications. Understanding these concepts broadens your ability to structure and organize your code, especially in complex scenarios like the ones we've discussed so far in this course to do with streaming log processing, genomic pattern detection, and stock price anomaly detection. Let's now head over to the hands-on coding session to see all of this in action. See you in a bit.